Okay, this is part 2 of probability distributions for continuous random variables. In part 1, I tried to put it all into context for you and sort of give you a grounding or a tangible idea of what it is that we were talking about. Now we're going to continue. I'm going to go back to normal distributions, which I think I mentioned in part 1. And then we're going to go on to uniform distributions and then other types of distributions, which I'll explain when I get there. But for now, we're going to talk about the normal distribution. With the normal distribution, we are going to use the empirical rule. So this is going to be review for most of us. The empirical rule. We are going to have more sophisticated methods of analyzing the normal distribution very soon. We're going to be using something called the normal distribution table pretty soon, but not just yet. So for now, we're going to look at the normal distribution and see how we can utilize it as a probability distribution rather than just simply as a distribution that allows us to see and understand the distribution of scores we might have in a data set. Now we're going to use it for probability. You're going to end up finding and seeing that it's really the same thing. Here's a normal distribution. In part 1, I talked about a data set where my mean was 5 and my standard deviation was 1 pound at that point. Let's make S equals 1 pound. Okay. That means that if the mean is 5, incidentally, one standard deviation above the mean, meaning to the right on the number line, if you want to think about it that way, is going to be 6 pounds. That's fairly simple. We're going to be using this because we're going to be asking questions like, what is the probability of randomly selecting a score from this distribution, from this population or sample, whose value is between, for example, 4 and 6? So it's almost the same kind of question that we were looking at earlier in statistics, only now instead of saying, what's the proportion of this distribution between 4 and 6 pounds? Now I'm asking you the question, what is the probability of randomly selecting a score between 4 and 6? But otherwise, it's really the same thing. So we're going to be using the empirical rule, and I'm going to write out some questions here for you, and I want you to work them. I want you to pause the video, and I want you to work these problems and then unpause when you're done, and I'm going to give you the answers. We're going to work them out. So give me a moment while I write these down. First question. First question reads, what's the probability of randomly selecting a score from this group whose mean is 5 and standard deviation is 1? What's the probability of randomly selecting a score between 4 and 6, or randomly selecting an individual whose birth weight is between 4 and 6? Okay. Second one, what's the probability of randomly selecting an individual whose birth weight is between 3 and 7 pounds? And finally, what's the probability of randomly selecting an individual from this group whose birth weight is between 2 and 8 pounds? Remember, we're still assuming that the mean of the distribution is 5 and that the standard deviation is 1. Go ahead and pause the video, work those, and then come back. Okay, let's go ahead and do those. I'm going to draw a picture of the distribution that we're talking about. Here's the mean, 5. One standard deviation above the mean will be 1 pound above the mean, so that's going to be 6. 2 standard deviations above the mean will be 2 times 1 pound above 5, which is 7. And so on until we get to 3 standard deviations above the mean, which is 8. In the same way, we can see that 1 standard deviation below the mean is 4, 2 standard deviations below the mean is 3, and 3 standard deviations below the mean is 2. 1 standard deviation, 2 standard deviations, 3 standard deviations. So by the empirical rule itself, the probability of randomly selecting an individual from this group whose birth weight is between 4 and 6 is going to be the proportion of this probability distribution that we're going to find between 4 and 6, meaning within 1 standard deviation of the mean. So from the empirical rule itself, by definition, we know that that's 68%. Likewise, with the next one, the proportion of this probability distribution between 3 and 7 is 95%, because that is the whole area of this distribution that's within 2 standard deviations of the mean, within 2 above and within 2 below. So that's going to be 95. And finally, this last one is the whole area of this distribution between 2 and 8, or in other words, within 3 standard deviations of the mean. So by the empirical rule, that's got to be 99.7. Good. Let's go ahead and do a few more. Let me get rid of that. And we'll continue. Here's some more problems. Okay, go ahead and pause. And let's go ahead and solve those. Let's draw another picture. Here's our distribution with the mean in the middle. We're being asked about the point of 4 and the point of 7. Now I can already tell those points are not symmetrical around the mean. To prove that to myself, I'm going to use the z formula. I'm running out of space here, but I'm going to write the z formula out here in the form that we use it for samples. And I'm going to go ahead and plug in the 4 and the 7 into that formula and find out what their z-scores are. So if I plug in 4 into that formula, I'm plugging in the 4, I'm putting the 5 where the mean goes, and I'm dividing by the standard deviation. I find that 4 is -1z. If I perform the same calculation for the 7, I'm going to have 7 minus 5, which is the mean, divided by 1, and then I get +2. Let me fix that a little. So that's +2. So I know that even if I didn't draw the picture first, which really you should do because it makes things a lot simpler, but just sort of as an excuse to utilize the z formula or to demonstrate how a person might confirm these things to themselves, we know that we're being asked about the zone that goes from -1z to +2z. That is not a symmetrical area, so we're going to have to utilize something more than just the basic empirical rule to answer this. So we're going to go ahead and do that. To do that, I'm going to divide this area that I want to solve for into 2 parts. The part that's to the left of the mean and the part that's to the right of the mean. And I'm going to analyze them separately, and what I find I'm going to add together. So I know from our earlier work that from 4 to 6 is 95%. And I know that this thing is symmetrical around the mean. If it isn't, it's not the normal distribution to begin with. So if it's symmetrical from 4 to 6, and for the moment I want only what's from 4 to 5, then I know that that must be half of the area from 4 to 6. And the area from 4 to 6 is 68%. So that cross-hatched area with double stripes has to be half of 68. So that's going to be 34%. That's half of 68. I'm going to write that down and then continue. Now I need the area from 5 to 7. Now, you may already understand where I'm going with this, but from 5 to 7 is going up 2 standard deviations. If I were to be looking for the area, I'm not, but if I were to be looking for the area that goes from 2 standard deviations to the left of the mean all the way up to 2 standard deviations to the right of the mean, that would have been 95%. But here again, I only want half. And I sliced it right in the middle. I decided to cut my calculation in 2 because doing so right at the mean allows me to utilize symmetry and to have these numbers. So I can cut them in half. This, from 6 to 7, the single striped area is half of 95. So that's going to be 47.5. If you add those two together, you're going to find that it is 81.5. Okay, let's continue. I'm going to redraw this. For this question, I may have to draw a little bit smaller. From 2 to 5. Well, 5 is the mean, so I'm going to draw only this much. That's 5, the mean. 1 standard deviation to the left of the mean is 4. 2 is 3. And 3 is 2. So I'm being asked to go from 2 to 5. One error in doing this, it's a lot of times, especially when people get good at this, they tend to think, oh, well, that's the whole thing on the left. So they answer too quickly, without thinking, 50%. But it's really not. This is the area from the middle to 3 standard deviations to the left of the mean. If you want to calculate it, use the z formula. You're going to find that that is a z-value of -3. So by the empirical rule, if we went from -3z to +3z over on the right, we would have 99.7%. But we don't have that. We have only the left-hand half of that interval. So it's got to be half of 99.7%. If you do the math, it's going to come out to 49.85%. That's half of 99.7. This is the question that asks us, what is the proportion of a distribution, of this distribution, that is just simply less than 5? So now we're being asked not only about this zone, but all of the thing going all the way to infinity on the left. And that is 50%. That's the answer to that. Okay, I'm going to erase and make a little room. And we're going to do one more. Let me get rid of this. Okay, let's try this one, final one. What is the probability of randomly selecting an individual from this group whose birth weight is between 2 pounds and 3 pounds? Let's figure that out. Go ahead and pause the video. Do try it on your own. And then we'll come back and finish it. Okay, so here we go. I'm going to draw just half of the distribution. Now, I already know where this problem is going because I wrote it. But you may not already. So I want you to plug in the 2 and the 3 into the z formula. You're going to find that, just as we've been saying, that that is the -3 z point, and that is the -2 z point. I'm going to show that to myself and reconfirm by filling in those values in the picture. Okay, that's negative 3z, 3 standard deviations to the left of the mean, and that's negative 2z, 2 standard deviations to the left of the mean. So I want to find out this area to answer the question. I'm going to have to use a different strategy here. What I'm going to do is I'm going to define a larger area that I already either know or can easily calculate. And from that area, I'm going to subtract an area that I do not want. And after I subtract my unwanted area, what I'm left with will be what I do want, the striped area. So let's figure out what this larger area is. Now you just did it a few minutes ago in some of the practice problems, but let's pretend that we didn't, and I'll just remind you how we did it. This is the negative 3z point, and this is the mean. If we went from negative 3z, meaning again negative 3 standard deviations from the mean, 3 standard deviations to the left of the mean, if we went from that point to 3 standard deviations above the mean, plus 3z, by the empirical rule, we would have 99.7%. Great. Well, this zone, this larger zone that incorporates what we want, is half of that. So I'm going to take 99.7 like we did just now, and I'm going to divide it by 2. Earlier we learned that that was 49.85%, so we'll be putting that in at some point. For now, I'm going to leave it that way. Out of that large area, I want only this. So I know that I do not want the area with dots. Let's figure out what that is. That's the negative 2z point. So I'm going to go from negative 2z, and I'm going to think in terms of going to positive 2z. I know that that's 95%. So this dotted area must be half of 95. So I'm going to subtract my unwanted half of 95. So that's how we're going to work the problem. Let's just finish off the math. I'm going to erase this to make more room for myself. And if I take 99.7 divided by 2, which is 49.85, and I subtract 95% divided by 2, which is 47.5, I'm going to be left with 2.35%, and that's the answer. Let me remind you guys, it is not a good idea, in my opinion, to draw out a normal distribution and just label the various tiles and zones with percentages. 34%, 34%, 13.5%, 13.5%, and so on, because it actually leads to error. You want to try to do these problems in a way that mimics the way that we just did that. So that's the normal distribution presented as a continuous probability distribution of a continuous random variable. We'll continue with part number 3.